Hi, so today we'll give you a quick walkthrough about the tutorial that we published. In this tutorial, we are building copilots and we are using LangChain and GPT4 or GPT3 or any other OpenAI models. So before we go into the code, so let me quickly outline what are the key components in building a copilot. So the first thing is a knowledge base, meaning that when you're building the Copilot, you have to give the knowledge base to the Copilot so that we can use it to answer those questions. So this knowledge base could be a mix of anything. It could be a mix of websites, it could be a mix of documents, videos, a bunch of other stuff as well. In this tutorial, we are taking an example of ARIA-XAI, where we have our knowledge base in website, PDFs, which is primarily research papers or white papers that we published, and then videos where we have talked about the product or tutorials and so on. So first, gather all these resources and load them and merge them. Once I prepare my knowledge base, then I need to start with chunking. Chunking is splitting these big documents into multiple subpieces so that I can use these pieces to create embeddings. So why do you need chunking? So OpenAI models has a limitation of tokens. It depends on the model that you're going to use. So if you're passing on a data which is more than that token limit, then you may hit a max token error, those kind of errors. And also, it's quite advised to create these chunks in a manner that you're not overly simplifying the context across large data sets. So once you do the chunking, so then you prepare the embeddings. So you can use OpenAI embedding model to create the embeddings. Once I created these embeddings, then I need to store them in a database. So you can either store them locally on your disk using ChromeDB or Faces, or you can use commercially available databases, which are also, I think some of them are also specialized in word vector-based databases, like PanCon or Quadrant. There are a bunch of new guys that are coming in, or else you can use traditional databases like Atlas DB or MongoDB and those kind of databases. So once you store these embeddings, then you don't actually need to do this exercise of collecting the knowledge base and doing embeddings, because you can use these stored embeddings to build your Copilot engine. So do this as an offline activity or maybe sequential activity. So whenever you have new updates in your knowledge base, then you can do the embeddings and update that. Or else you can simply start using your stored embeddings. Now, to build a Copilot, it has four key components. One is shortlisting the sources, which is search, document search or knowledge base search, as we call it as. So what happens is, okay, you have a bunch of data. Now you need to give shortlisted information to the Copilot engine, where it can summarize the answer or where it can give the answer to the user. So you need to, you can, LangChain has off-the-shelf things that it can do pretty much all of this. But if you are planning to do customized blocks, so you can actually build your own document search, prompting, memory blocks, and the conversation engine as well. In the tutorial, we have covered this, but ideally, yes, first you will start with the document search. Next is prompting. So prompting will tell the machine on what is its job, or give maybe a bit of learning in few shots or a single shot kind of inputs. The third is the memory block. So memory block is necessarily remembering what was the conversation was before answering the next question. So this is primarily a summarization of previous conversations, or as he's remembering the previous conversations and using them while answering a new question. And then the final one is anyways the actual Copilot engine, which actually uses all of this and then replies or answers to a question. So these are the basic blocks, and this basic blocks remain same irrespective of any LLM that you're going to use or any kind of embedding model that you're going to use actually. So let's start quickly on the tutorial. So I've installed the needed libraries, imported them. Now preparing the data, I used ARIA-XAI website, which is xai.aria.ai. I'm using sitemap because in sitemap, we always provide the URLs or the websites where we want everyone to see. The rest of them, we would definitely want to hide, so I don't want to use and scrape the entire website. Now I loaded those URLs and scraped them. So you can see the actual page content. So here is my page content. And you can also see the metadata. So for example, here you could see the metadata is this, which is the URL from which it has extracted this information. Now, likewise, I've used LangChain's predefined loaders. By the way, so you could use, there are a bunch of loaders that are available in LangChain. For example, Tesco's document loaders. So here you could see there are a bunch of loaders that are available. So depending upon what is your knowledge source, you can use any of these document loaders. Or you could also use Llama Index, which is previously GPT Index. So they also have loaders, bunch of loaders for doing the pipelining. So once you loaded those documents, so I've loaded my PDFs, I loaded my text files, which is transcriptions from my videos, then I created a single knowledge base file by merging all these separate knowledge sources. So you could see that my total word count is around 161,000. Now I need to split them into multiple chunks, right? So this is where I'm using a recursive character text splitter. So you could use other text splitters as well. So here I'm using recursive text character splitter. You can use character text splitter or LLTK text splitter or any other splitter which works for your purpose. You can simply replace this with the respective option. So here I've defined the chunk size and the overlap. So chunk size, as I said, is one of the elements that you can use to customize and so which works best for your use case. Then I've defined my API key. Here I'm using Pinecone because this is hosted. So I want to use a scalable database. Pinecone is one of the options. You can use Quadrant or you can use some other options that are available. In fact, all these are actually, again, available in LangChain as well. So now I've defined my key, Pinecone key, and environment where it has to launch that index. So when I run the embeddings, it creates a new index and starts storing those indexes there. If you have very large large knowledge base, it is advised to add the embeddings in a batch size, maybe 100 batch size or 500 batch size like that. But in this case, I think this is smaller data set. I don't think I would need to do that in batch size. So if you're using it for a demo purposes, you can use Chroma or Faces. So you can uncomment this and use those data sources there. So far, I've uploaded my knowledge base and created the embeddings out of it. As I said, so this is a one-time exercise. So you can do this separately. Here comes the actual production related code. So one is you define the index where your embeddings are there. And then here you could see that it has added a total of 1594 total vectors. Now you load those embeddings. So once you loaded them, now it's ready to be used. So here I'm using LangChain's modules. So there are a bunch of modules, in fact. So you can, if you go to chains, you could see a bunch of options that are available for you. So question answer with sources, for example. This is using load QA with sources chain. I'll quickly tell you what it does and how can you use that. You also have retrieval, Q&A, answering chain. So this also does the same thing. It does the QA and also provide you the sources. So if your use case is a simple QA engine, so you could use a bunch of options that are available in LangChain. So you define the LLM and define the chain which you want to use for Q&A and get the source documents. So there is actually not much difference in the chain type for the same question, unless some of them will allow you to do a lot of flexibility and optimizations. That's the big difference. And then the hyperparameters you could always optimize for your use case. So once I defined it, then I created my initial prompt. Then I defined my first query. So here my query I've given, and then prompt is my initial prompt. Now I can, once I run this, then I can see the result. The result is basically the answer for the question that I asked, which is how is REXAI is going to help if I'm in banking industry. So it is giving me a simple textual answer, which is good. Now I want to understand where the answer is coming from, which is the sources. So you can click on result source, then you can get the page content where the model was using to create this answer. And you can also get the source URLs as well, source URLs or source links, whatever you want. So you can use and show them when you are answering a question. So far you have seen this, a very simple implementation of a QA module where I am using a LangChain. chain called vector dbqa, which helps me to retrieve the source documents as well. So I've given the prompt, result, and the source documents. Now, let's say you want to customize this. So you want to define the search, the document search as a set. So here you can define the docu search separately. Here I'm using again LangChain's LangChain similarity search to search for the documents. And I'm passing these documents to the QA engine, which is load QA with sources chain. So where I can define input documents is equal to docs. So now I can replace this with my own document search. So instead of using this, let's say I want to use some other kind of document search with a different kind of similarity scoring. Then I can do that. I can shortlist the documents and pass the documents to my QA engine for answering the question. So it answers the question, and the sources is anyways coming from the document search that happened. So I can see the sources as well. So this, if you want to customize, search and use the QA chain, load QA chain with sources, you could do this. So far we talked about QA kind of capability, right? Now, let's say you want a conversational kind of capability in your Copilot. So the key difference is, the remaining things will remain same. So the key difference is the memory block. So this is my memory block. So to build a memory block, what I'm doing is I'm storing my previous result and previous query, and I'm doing a summarization of that Q&A. What was the question? What was the answer? Summarize it and store that summarization so that I can pass that summarization when creating a new prompt. So this becomes my new prompt for the follow-on question. So the follow-on question will have initial prompt and summary of the conversation, and then that goes to the query, so that it knows that, okay, this was the conversation that has happened so far, and this is my new question. Now the system can use a new question and answers that new question. So why do you need to build your own custom memory? Actually, unless your use case is very critical and you want to optimize a lot of things, you could actually use LangChain's off-the-shelf memory blocks. So here you could see memory. So there are a bunch of options where you can actually build your own memory block or use LangChain's memory blocks. So the reason why we build memory block is because we may want to prioritize certain recent conversations as compared to earlier conversations. So we want to play with when to do summarization, when to use the conversation as is. But again, so feel free to use the LangChain's off-the-shelf memory blocks, or else you can build your own memory block from scratch. So once I define it, now the module remembers the previous conversation. So here you could see a quick snapshot of it. So it picks up the question and it picks up the follow-on question and uses it to answer it. Again, so far that's good, but I think there is a large scope of improvement from what we have built so far. So now let's try to optimize a little further, right? So here I'm going to build a custom search functionality. In this case, I picked up embedding model. So here I'm using OpenAI embedding model, or else I could actually use some other embedding model. So if I do not want to use that. So the process will be pick up the query, embed it, and do the search of that embedded vector with the vectors that you already have stored. Pick up the top 4 or 3, whatever you want to pick up the results as. So this becomes your docu search results, right? And pass on this results to your conversational engine. So here I'm trying to block, I'm trying to create my own document search as well. Pretty much I can define my own embedding model. I can define how many results I want to pass, or if I want to define a similarity score, I could do that as well. So here I can actually do a lot more customization than which may not be possible if you use LangChain's off the shelf. Yeah, I think LangChain off the shelf also allows you to do a score cutoff on similarity scores as well. But again, as I said, your use case may be different, but this is one way to build a customized document search. So once I picked up those search results, so I picked up the text from these search and pass that as context in my prompt and along with my query. So this is the example of the output. Now for the QA engine, so I'm using OpenAI's completion API, so I can use that and get the answer from. So here, instead of completion, actually, so you could use chat completion because this is more of a Q&A engine. So you may face errors if you continue to use completion, because it primarily treats this as a completion exercise rather than being a conversation exercise. So chat completion is the new API. Again, that is our next block of the tutorial. But necessarily, if you want to customize this document search, you can do that and pass that information to your conversational engine. Now let's customize this few more pieces, right? So one is, okay, I've defined my custom document search, and I define my prompt, but I want to give more advanced prompting method. So if you're using chat completion, so it does has more advanced prompting methods. Here you could see the roles. Roles is system, user, and assistant. So assistant is the answer that it is supposed to give. So you can use this to do a few shot learning or one shot learning. So here I'm kind of doing one shot learning, where I've defined my prompt, and in the prompt I told it how to act up, what is its job to do. Now you could, if you're doing few shot learning, this would become multiple lines, like A versus B versus C, and C versus D. So all these question answers, you can give it as a role as within the prompt, within the messages, and then the new prompt will become the prompt for which it will start looking at the question. But it goes through all the sequence of prompts that you have said, and then takes the last prompt to actually answer the next question. So this is one smart way of doing few shot learning. So this can be really helpful and really powerful. So you can play with this actually, and try to see what suits best for your purpose. So I've defined my conversational engine. So pretty much I've done all the components that I need. So in this case, this example was one Q&A kind of example. And then when it comes to conversational memory, you could see I've defined my document search, my conversational engine. Now I'm doing the same thing like what I have done earlier. I just replaced the conversational engine and in place of the previous conversational engine. So here you could see that I'm using the same memory block, nothing different. And then, yep, so this is pretty much the conversational engine. So I have replaced, I'm using the new engine now. Now, if you look at answers, the depth of the answers, for example, here my question was, what is RAXAI? It is an ML observability tool for mission critical AI functions, blah, blah, blah. And then how can I use it for banking? So it actually details me a very good answer. So you could see that you can enhance the Copilot's performance answer. And if you are able to customize some of these blocks, you could actually reduce hallucination as well. So try to use these components and optimize it as much as you can, so that you are publishing a very good Copilot, which handles a lot of exceptions as well. So here, the same thing is what I have hosted in the hosting in Streamlit. So here you could see the responses that I kind of mentioned earlier. So here I can see what is REXAI, and I can see how can it help me in banking, vagera, vagera. So now, as I've already answered this question, so let me ask a new question. Into lending based off India. Can it help me to Yeah, so I'm kind of asking multiple things, and I'm referring to the previous conversation as well. So let's see what the system responds. One of the things that we realized was this API GPT4, which in fact I think kind of slipped my mind, but yes, so we are using GPT4, so you can use GPT3, GPT3 Turbo, or any other model that you want. But these APIs are quite slow, so it's going to take some time before you get the answer. But all in all, let's give some time for the response to come in. But you can go through this tutorial, feel free to play with it. And LangChain is absolutely fantastic. It kind of simplifies a lot of things when you're building Copilot. It gives you a lot of additional functionalities as well. So yeah, kudos to those guys. If you are facing any issues or if you have any questions, feel free to reach out to us. You can comment it in the video or in our blog. We'd be happy to answer them and try to provide answers to those things. And from next step standpoint, I think next thing that we would be experimenting is two things. One is using the agents. OpenAI has agents now, so we can use those agents to call third-party APIs or our own APIs and make it execute certain actions as well. That is one which we would be happy to publish sometime very soon. And second was building the same Copilot on a different kind of LLMs, maybe Alpaca, or one of the things that we are looking at was Alpaca actually. But again, we'll keep you posted once we publish those tutorials. Yeah, so the answer is here. So now it says that, so yes, RA XAI can help you to address AI regulations. RBI has recently formed up a framework for digital lending. Additionally, it helps you to promote blah, 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 all of this. So I think building a Copilot is going to be next way of knowledge sharing. This is a simplistic way. I think we are going to see a lot of subject matter experts, Copilots, or product specific Copilots. So yes, given that as a future, so feel free to play with this and let us know how the experience was. Great, thank you.